Good morning, dear friends. Today we are going to see a new topic, that is Earth gravitational acceleration. We will call that one acceleration due to gravity. Last class we have seen Kepler's laws and a derivation. How Kepler's third law is helped Newton in coming to a conclusion of his inverse law. Today we will see what is acceleration due to gravity, what is the value of acceleration due to gravity on the surface of Earth, what are the factors depending on acceleration due to gravity, when an object is at the center of the Earth, what will be the value of acceleration due to gravity. These are the topics today we are going to see. So first of all, while starting the lesson only, I told you what is acceleration due to gravity. What is that? So last year we have studied Newton's three laws of motion. So according to Newton's second law of motion, every action has an opposite and equal reaction. Now we know that Earth gravitational force. Okay, what is Newton's law of gravitation? Okay, Newton's law of gravitation states that everything in the universe, whatever object is there, it is attracting each other. Every object in the universe are attracting each other. Now, consider one object is moving vertically downwards towards the surface of the Earth. Now, when the body is moving downward, Earth is attracting it towards it. It is the action. Because of that, there will be a reaction. What is the reaction? Because of this attraction, the acceleration, the speed of the velocity of the object is going to vary. This is known as acceleration due to gravity. Now, what are the factors depending on this acceleration due to gravity? Before that, we will see what is the value of this acceleration due to gravity. So, what is gravitational force equation? Gravitational force is represented by the letter F. F equal to G M divided by R square. We know this. This is what is G? Universal gravitational constant. M, the mass of the Earth. Small letter m, the mass of the moving body. R, the radius of the Earth. Okay. Now we are going to derive the value of acceleration due to gravity. That is small letter g. So according to Newton's second law of motion, what is the equation for Newton's second law of motion? F equal to ma or mg. While a is acceleration due to gravity, that is mg. Acceleration due to gravity is denoted by the letter small letter g. Now, so what we are going to derive? G. So G equal to F divided by M. G equal to F divided by M. What is the value of F? That is G M divided by R square. Let's substitute that. G equal to, first we writing the value of F. Okay. G M divided by R square, the whole divided by M. This is a single thing. Okay. So we can cancel this one. So it will become Gm divided by R square. We know the values of G. What is that? 6.67 into 10 to the power minus 11. Same way, mass of the Earth and radius of the Earth values we need to substitute in this equation. Hope you take a note of this one. So G equal to, first we are going to substitute the value of capital letter G. 6.67 into 10 to the power minus 11. Next, M, the mass of the Earth. That is 6 into 10 to the power 24 divided by the radius of the Earth. That is 6.4 into 6. R square is there. So the whole square. Okay. When we solving this one, we will get a value of 9.77 meter per second square. Okay. So this is the value of acceleration due to gravity on the surface of the earth. Okay. One more time I am saying, first we are starting from the equation F equal to G_m divided by R square. Okay. From there we are taking the Newton's second law of motion equation. F equal to mg. Therefrom we finding G equal to F divided by m. Next F value we going to substitute G_m divided by R square divided by m. M getting cancelled, remaining Gm divided by R square. Substituting the values, we will get the 9.77 meter per second square. Now, next we are going to see what are the factors depending on this value. Will this value same all over the places of Earth? No, it varies. It varies according to 3 factors. What are the 3 factors? In your textbook, page number 8, you can see the 3 factors. It changing along the surface of the Earth. So, we know the shape of the Earth. The shape of the Earth is somewhat similar to a sphere. So, these 4 areas what we will call, these are the poles. North pole, west pole, east, south. Okay. Now, this center region, we will call this one as equator. Now, along the poles, okay, the poles are little flat. Okay, don't consider Earth as a perfect sphere. It is not a perfect sphere. Earth poles are little flat, and near to the equator it is bulging. Okay, this is the shape of the Earth. So, the maximum value of acceleration due to gravity will be at these poles. What will be the value? It is 9.832 meter per second square. What is the value? 9.832 meter per second square at the poles. All the poles, this will be the value. Now, when we moving to the downside, okay, when we coming latitudinal way, the value of acceleration due to gravity is decreasing. So, near to the equator, it will be minimum, that is 9.78 meter per second square. 9.78 meter per second square. So, at the poles, the value is 9.832 meter per second square. Near to the equator, it will be minimum, and it is 9.78 meter per second square. This is the first factor depending on along the surface of the, meaning along the factor is shape of the Earth. What is the second factor? Change with the height. Okay, change with height means consider you are standing over here. Okay, what will be the acceleration due to gravity? It is 9.832. You going for a 100-meter height. Okay, the value will decrease. It is 9.831. Again, you going for another 1 kilometer height. The acceleration due to gravity is decreasing. So, when the height is increasing, okay, means when we are away from the surface of the Earth, the acceleration due to gravity decreases. This is the second factor. Okay, next, the third factor, change with the depth. Now, a person is going inside, or any object, it is moving inside the Earth. Okay, now what will happen? The same thing, the acceleration due to gravity is going to decrease. So, all the 3 factors, one more time I am saying, first factor is, it is changing according to the surface of the Earth. maximum at the poles, minimum at the equator. Second thing, change with the height. If height is increasing, acceleration due to gravity decreasing. Change with the depth. If depth is increasing, acceleration due to gravity is decreasing. These are the three factors depending on acceleration due to gravity. Now the last topic we are going to see at the center of the earth. Okay, what will be the value of acceleration due to gravity? Yes, we know that acceleration due to gravity is 0. So we are going to prove it how acceleration due to gravity is going to become 0 at the center of the earth. Okay, now we are going to treat earth as a sphere with a uniform density. Okay, it's a sphere which is representing our earth. Okay, the outer one. Okay, consider one object is there at the position A. Okay, it is moving towards the center of the earth. Now it reached to another point known as P. So this much area it has been traveled. Okay, this area it has traveled. Remaining is this portion. So the radius of earth is represented by OA. OA equal to R, which is our radius of earth. Now the object is at P. So OP is the remaining distance. So this is the distance traveled by the object D. Okay, OA is the total radius. So OP equal to R minus D. Now we are going to derive how this value is going to become 0. So you can refer your digest page number 21. Okay, we are going to do it with the help of gravitational force equation. F equal to G m dash divided by R minus D square. Okay, while m dash is the mass of the earth, m is the mass of the moving particle, R minus D is the remaining distance the object need to travel. Okay, now we studied in smaller classes. 8th class we have studied one equation of density. What is the equation of density? Density equal to mass divided by volume. Okay, and we know the value of volume of a sphere. What is the equation for volume of a sphere? Volume of a sphere is equal to 4 by 3 pi r cube. Okay, volume of sphere equation is 4 by 3 pi r cube. Now we are going to find m. Okay, m dash value we are going to find it. Okay, m dash means what? Mass. Okay, mass equation how can we form from this one? Mass equal to volume into density, right? So mass equal to volume into density. Okay, so first what is the volume equation? That is 4 by 3 pi r cube. Here r means radius. What is the radius? It is r minus d square. So equation will become m dash equal to 4 by 3 pi r minus d. In the place of r, what we need to write? R minus d, and it is cube. So r minus d cube into. Now the portion of volume is over. Now what is remaining? Density. Density equation what? Density is mass divided by volume. So mass m divided by, what is the equation for volume? 4 by 3 pi r cube. Okay, now see what are the same terms we can cancel it. 4 by 3 pi, 4 by 3 pi is getting cancelled. Remaining what is there? R minus dq m divided by r cube. R minus dq divided by r cube. Okay, this is what? This is m dash. Okay, now we found the value of m dash. Remaining term, yes, we are going to substitute this value in this equation. F equal to gm divided by r minus b square. In this equation, we are going to substitute it. So F equal to gm, okay, divided by r minus d square into what is there remaining? M dash is there. M dash value is r minus d cube, okay, divided by r cube. Okay, now r minus d square, we can cancel this one. Remaining will be gm r minus d divided by r cube. Okay, now consider the body reached to the center of Earth. Then what is the distance traveled by the object? It is equal to the radius of Earth. D will be equal to r. So in acceleration due to gravity, we see an equation g equal to f divided by m. We are going to substitute that equation here. So it will become g equal to, what is the value of f now? It is gm r minus d divided by r cube. Okay, so gm r minus d divided by r cube. Okay, f by m is there, so m are getting cancelled. So the d value, okay, the distance traveled by the object when it is reaching to the center of Earth, it will be equal to the radius of Earth, meaning d will be equal to r. Okay, then we can rewrite this equation one another way. G r minus r divided by r cube. Okay, r minus r means what? 0. 0 into any term, it will be 0. 0 divided by any term, it will be 0. So we can conclude that g equal to 0 when it reaches to the center of the Earth. Okay, so by here we are going to conclude today's topic. If you have any doubts, please clarify with me. Okay, you can message me in WhatsApp. Okay, thank you. Have a nice day.